Section 22.27, Alkene Metathesis. In this reaction, two alkene molecules exchange their functional groups. In the product, we have R1 and R2 bonded to the two carbons of the same double bond, and also ethylene is produced. Now let's look at this catalytic cycle. Over here we have transition metal bonded to CH2, a singlet carbene. A singlet carbene may form a sigma bond with the metal using its lone pair electrons. Meanwhile, the transition metal may donate two d electrons back to the empty p orbital centered on the carbon of this singlet carbene. So that's the electronic structure of this MCH2. MCH2 may react with the first alkene here with this R1 functional group. And this is similar to the 2+2 cycle addition in organic chemistry. In organic chemistry, if you have two carbon-carbon double bonds, the 2+2 cycle addition is thermally forbidden because the symmetry of the HOMO of one double bond does not match with the symmetry of the LUMO of the other double bond. There's no way for the HOMO of one molecule to interact with the LUMO of the other. However, in here, this M forms a pi bond with CH2, not using its p orbital, but using its d orbital. So if you imagine a d orbital here, if you have plus, minus here, and then on the opposite side, you have minus, plus. So again, on the left-hand side, if you have plus on top, minus on the bottom, and then on the right-hand side of the metal, you have minus on top and plus on the bottom. So the lobes on the right-hand side can interact with the p orbital of the other alkene molecule. That's why this is thermally allowed 2+2 cycloaddition reaction. Only because this transition metal is not using a p orbital, but a d orbital to form this pi bond with CH2. So now we can go from here to here by losing a ethylene molecule. This is just 2+2 addition reversed, and then this second alkene comes in and form a four-membered ring again. And again, this is 2+2 cycloaddition, thermally allowed. And then finally, the reverse 2+2 cycloaddition. Now we get this catalyst, M double bonded to CH2, plus this product. Both R1 and R2 are bonded to the same CC double bond, of course, on different carbons. This kind of reactions are very useful. I'm showing you a few examples. This is table 22.12 in inorganic chemistry by Weller et al. So you can take a look at those reactions. Again, you have two alkenes that exchange their functional groups in those reactions.